this video, we will discuss about some of the important concepts and also the formulas you need to know for your circular measure. Your Form 5 ADDMATH, Chapter 1, Circular Measure. Before we go to the formula in this chapter, we need to have a recap of previous chapters from Form 1 to Form 3 and also from your Form 4. So the first thing is what? The first thing is knowing your terms. First thing is know all the terms from inside the circles. What are the terms? Okay, this is a circle and here is what? The central point lah. Usually they will label it as what? Label it as O. And then when you draw a line from a center point and touching the circle, what is this called? This is your radius. And a lot of time, the question will do what? The question will give you diameter to make you confused, to make you what? Make some careless mistake. He tell you, oh, diameter is 8 centimeter. And then when you do your calculation, you sub in your formula, you didn't divide by 2. Remember, what is diameter? Diameter is the line that touches the center point and touches the circle, like this. This is diameter. So diameter is usually what? 2 times the radius. If your diameter is 8 cm, what should your radius be? Your radius is 4 lah. 4 cm. This is the basic one. And then when you draw a circle, you draw what? You draw 2 radius. And then you can see what? This is what? This is a sector. Then you think, if this one is sector, this one lah. Is this one not a sector? This one also sector. So now how to differentiate them? The smaller one, we will call them as minor sector. The bigger one called as major sector. And then, how about here? What is the length here called? If it's the whole circle, it's called what? It's called the circumference. Circumference. But I don't want the whole circle. I just want a part of it. It's called as what? It's called as arc. Arc length. Later we'll talk about the arc. And the same thing. Here is an arc, right? Here's the arc of this circle. Then how about here? Is here not the arc? Here is also an arc. Then how to differentiate them? Same thing lah. This is the minor one. And this is the major one. So after we talk about sector, we talk about what? Segment. What if now I have one line that touches the circle, but then not the center point, like this? What is this line called? Is this a radius? No, right? This one is not the radius. This one is known as the chord. Then if this is a chord, is this a sector? No, this is called as segment. And I think you should know this one is a small segment, so it should be a minor segment. And the large one is what? A large one is called as the major segment. This is some of the terms you need to know lah. And know the term what? Perimeter. This is all the term for the circle. And then you need to know the term for perimeter. What is perimeter? Okay, it's like the total length of something, the sum of the length of something. This is A, B, C. Perimeter is the sum of it, A plus B plus C. Like, it's how long is this thing? Here, plus here, plus here, and plus here. That is the perimeter. And then you need to know what? You need to know something called as the tangent line. So you got your circle, right? Now you got one line, right? It touches your circle at one point. Maybe there's one line here. Just go and touch here and then go. This is called as what? This is called as the tangent line. Tangent line. It touches one point of the circle, only at one point. What is so special about this tangent line? You need this because when you draw one line from the center to the tangent line, it will be what? It will be 90 degree. 90 degree. It will be right angle. You need to know about this because later, when you have two tangent line, okay, now I have another tangent line touching at one point. I draw one line from the center point and touches the tangent line, it forms another 90 degree. And now if I divide, this is like have four sides, like this is a quadrilateral shape. And then I divide from the middle. I have two triangle. And we can do a lot of calculation from here lah. But the basic is here first. Know all your terms. What is a segment? What is a radius? What is an arc? What is diameter? What is your chord? Everything you need to know first. If you don't know, later when you do, I need to sub using the wrong formula lah. The second thing is what? Second thing is knowing your trigonometry, your sin cos tangent, trigo. What? Your soka tua lah, basically. Soka tua. So, if you understand this part, you can skip first. But if you have a very weak basic, you can listen to this. This soka tua, sin cos tangent, is used for what? It's only applicable for what? For a right angle triangle. Right? Bro. Right angle triangle. Where you see what? The 90 degree. If the triangle is something like this, it don't have a 90 degree, you cannot use sin cos tangent like here, you cannot use it. So if now this is the angle, okay, you need to know three things: opposite, adjacent, and your hypotenuse. Okay, hypotenuse is what? It means the longest line here lah. And then if you don't know which one is the longest line, you should look at what? Look at the 90 degree. The line opposite of this 90 degree will be your hypotenuse, your H. And now, decide which side is opposite and which side is adjacent. Look at the angle. The opposite of the angle, opposite, this one will be the opposite. What does adjacent mean? Adjacent means beside. So there's two lines beside of this angle, you can see or not? You see here, this is the angle, right? There's two lines beside the angle. But this line is what? This line is hypotenuse. So it must be this line that is adjacent. So your Sokata is say what? For sine is opposite over hypotenuse. For cos is adjacent over hypotenuse. For tangent is what? Opposite over adjacent. This one should be a basic, so I just briefly go through lah. Another thing you can use for right angle triangle is your a squared plus b squared equals to c squared. Pythagoras theorem. And then it should be A, B, and C. This basic, so I don't want to go so deep about this. So we know like if there's a right angle triangle, you can use sine cos tangent, and then you can use Pythagoras theorem. But when the triangle is not a 90 degree triangle, is not a right angle triangle, what should you use? Here we talk about the solution of triangle. I think you learn this in Form 4 lah. Solution of triangle. You apply solution of triangle when you have what? You have triangle which are not a right angle triangle, okay? You have three things. First thing is sine rule. Sine rule. Like, you have sine rule, but you need to know like, when should I use this sine rule? When you have two sides and two angles. but you need to see how the sides and angle works. So when I draw a triangle, I will label the length as what? Label the length as A. And then A has what? A have its own angle A, where? At the opposite of it, opposite here. So here it's angle A. If I label here as the length B, the opposite of it should be angle B. If here is length C, the opposite of it is angle C. For two sides and two angle, right? You need to have, if you have length A and length B, you should have angle, length it should be A and B lah. You should have angle A at angle B. You only can apply when you have both these, like the respective side and angles. You can only use sine rule when you have the respective side and angles. Let me show you an example. Example of it, how you use the sine rule. So now, maybe you are given what? You are given, here is x. You want to find the length of x. And then the angle is 30. And then he give you like this side, the length is what? The length is maybe 4. And then the angle is maybe 50. So how should you write the formula? You can write 4 over, should it be sine 30 or sine 50? It should be sine 50. This one is one pair one. It's opposite of it, one pair, equals to x over sine 30. This is how you should do lah. Use the formula. The very, how to say the general one, the formula is what? It's A equals to sine A equals A over sine A equals to B over sine B equals C over sine C. This is the general formula lah. You can take any two of it. Maybe here also can, here also can. Just take two of it, just equal them up, and you can use this formula. If today they give you what? They give you 50 degree, but then the length they give you here is maybe it's 5, I don't know, 5. Then can you just do like, oh, okay, the length is 5. 5 sine 5 sine 50 equals to x over sine 30. Cannot. If you use 5, this length, right? If you use 5, you should use the angle opposite of it. Should use this angle. So how should you do? Use 180 minus 30 minus 50 lah. Then you should get the angle. Sine, this one should be 100. Sine 100. This one is the correct one. So remember, you use the side and angle, they should be the one as a pair one. Like this, like this. This one is when you use the sine rule. The second one is what? Cosine rule. When do you use cosine rule? When you see what? When you see there's an angle and there's two lines beside it. Usually they'll provide one lah. Okay. One angle and three sides. You have one angle and three sides. One angle and three sides. So usually it's like A, B, and then this is C. What is the general formula for it? It's C square, which is the length opposite of the angle, equals to A square plus B square minus 2 AC, AB, and then cos C. The C is the angle theta here. This is what, like, when you see like, oh, okay, usually they give like this, they give an angle, and this one is 3, and this one maybe is 4, and okay, find the length of here, x. Then now you only have one angle. You don't have two angles. What should you use? Can you use sine rule? Cannot, right? Then what should you use? You want to find this length. So you see, oh, I got one length, two length, and 3, even though it's unknown, but you need this one, right? And then an angle. I have one angle, so I use cosine rule lah. Another way you see is like there's one angle between two lines. It's always have something like this. One line, two line, and then you have one angle here. If I explain in Chinese, it's like something in the middle. You 架住那个 angle. There's an angle 被两条 line 架住，夹住。This is for cosine rule. Then the third one is what? The third one is the area. The formula to find the area of a triangle. If it's a right angle triangle, it's very easy lah. Aya, what? This one, the base times height times 1 over 2, 1 over 2 times AB. Easy lah. But then when the triangle is not a right angle triangle, what should you do? It's a very weird angle, then you use this one. It's something similar as the cosine rule. You find this one angle here, right? And then this angle, you can find like the two adjacent line that form this angle. You find the line of it. Maybe this one is 5, this one is 6. Then you just find like area equals to 1 over 2, 5, and 6, and then sine theta. This is how you find the area of a triangle. If you want the very general one, area equals to 1 over 2 AB sine C. C should be the big angle lah. This is the area of triangle. And you should know all of this formula, I think, from your Form 4 syllabus, but you need to use all of it in circular measure when you're calculating the triangle. Later you'll see how. So this is just a recap of it. Another way of finding the area of triangle is what? Is the Heron's formula. When do you usually use this? When they ask you to use and when you see there's no angle at all. Only what? Only sides provided. The sides length provided. This is the time when you use the Heron formula lah. Heron formula is A equals to square root S minus A, S minus B, and S minus C. What is S? S equals to semi, it stands for semi-perimeter. Remember we talked about perimeter? When you have a triangle, length A, B, and C, perimeter is A plus B plus C. So what is semi? Semi is half. So S equals to A plus B plus C divided by 2. So when you got this, then you just sub into this formula and you should get your area lah. This is all the formulas of it. After mastering the formulas, the basic, before entering the circular measure, you now enter to the formulas that you need for what? That you learn in your Form 5 syllabus, the chapter. Okay, the first thing is what? You'll be exposed to a new kind of unit for your angle. I think from Form 1 to Form 3, you learn your angle in what? In degree. Oh, what is this angle? It's 30 degree. What is this angle? It's 90 degree. But it's just a unit, right? It's angle in what? In degree. You can think in another example. A line, it can be what? Line can be in cm, can be in meter, can be in km. So angle can also be in another unit, right? So today we give you another unit. Is what? It's radian. Radian. And think about cm and meter. How do I convert centimeter to meter? You divide by 100. So how do I convert from degree to radian and from radian to degree? An easy way is like this. Before we know like how to convert, you need to know what is a radian first. Knowing what is radian is it's quite important concept for you. Like it's a very small concept, but you know it, I think it will be easier for you to understand. Why do I do this conversion? Why do I need to have like pi over 180 or 180 degree over pi? What is this? Okay. What is 1 radian? angle 1 radian. My theta is 1 radian. How do I know it's 1 radian? When your arc length, remember or not, your arc length is equals to your radius. It's equal to your radius. For example, today you have a circle and then you draw a sector. Your radius is 5 cm, 5 cm, and when you calculate the arc length is also 5 cm. When you have these thing, oh, my arc length is equal to my radius. Your angle is called as 1 radian. 1 rad lah, okay. 1 radian, right? For 1 radian, when your angle is, wait, angle. When your angle is 1 radian, your arc length is how much? It's equals to the radius. Equals to the radius or the r lah, okay. So if my angle is 2 radian, my arc length is equals to 2r. So if the same goes with 3 radian equals to 3r, 4 radian equals to 4r. But today, if I want to say the whole circle, how much should it be? How much is the whole circle? If I say it's pi radian, it become what? It become pi r. If the whole circle is how much? The circumference is how much? Is 2 pi r. So when the angle is 2 pi radian, it become 2 pi r. So what does this mean? This means that the angle for the whole circle is equals to 2 pi radian. So from here, if this one is for what? The angle in term of radian. For the whole circle, the angle in term of degree is how much? It's equals to 360 degree, right? So we know that 2 pi radian is also equals to 360 degree. Then pi radian is equals to how much? Equals to 180 degree. That's where your 180 degree and pi comes from. Okay, this one is just for you. Like it's like almost like extra knowledge, even though it's in your textbook. But to convert your degree to radian and radian to degree is actually very easy. Degree and radian. So you need to know two things lah. One is pi. I use pi for my radian, and for degree I use 180. And this is how I remember this. Actually, it's using a ratio concept. But if you don't want to know the ratio thing, you just want it to be very easy, just memorize it. This is how I memorize lah. You times and times lah. Now you want radian. Something you want, it's you put up. You put at the up. You don't want what? You don't want degree. You divide by something you don't want, you divide it. You divide it. You don't want them to have a very small group. You don't like maybe like now you are the teacher. You are the teacher. You don't like the boys every time they sit together and they make a lot of noises. You don't want them, okay? You cannot sit together with the boys, so you divide them out. Okay, you go sit here, you go sit here, you go sit here. You don't want them to sit together. So now something you don't want, you divide. You are changing degree to radian. You want radian. You don't want degree, so you divide by the degree, 180. Now you're changing the radian to degree. You want what? You want degree, right? So you times by 180. You don't want radian, you divide by pi, pi radian. This is a very easy concept to memorize lah. So you just need to know this one. But if you want to know in terms of what? In terms of ratio, it's actually ratio lah, okay. If 2 pi radian is equals to 360 degree, right? Now, you're given angle in degree. Maybe it's like how much? Maybe it's 170 degree. How much radian is it? I don't know. Then you just put as what? X radian. X radian. So now you do what? You do what we call as a cross multiplication. You cross it. So it's x times 360 degree equals to 170 times with 2 pi. And now x is equals to 170 over what? Over 360 degree times with 2 pi. This one is what in terms of radian lah. You can see here, right? Actually, if you cancel out what? The 2 and the 360 is actually pi over 180. It's actually 170 times pi over 180. So this is how it's come from lah. If in terms of, if you want to understand it in the ratio, it's actually ratio. If 2 pi radians is equals to 360, then how much is 170? So you just use ratio and you can find it. This is the conversion of units of the angle. The second thing you need to know is what? Okay, later we'll come to this question. The second thing you need to know, second formula is about arc length. Arc length, we use a symbol, arc length, we use symbol S to represent it. S equals to r theta. R is stand for radius, and this theta is actually your angle. But in what? In what unit? Now we have two units. In radian. In radian. Remember when you use this formula, your angle will always be radian. But actually, you learned another formula before during your Form 1 to Form 3. To find the arc length is what? If circumference is 2 pi r, but you know, right, the 2 pi r is for 360 degree. Now, I got maybe this one is 160 degree. I only want this part. Then, you just 160 degree over 360 times with 2 pi r. This one is the formula you learned before during your Form 1 to Form 3, right? You can find the arc length of it. It's actually the same concept. This one is what? This one, wait, I mean like this formula can actually come from here. This one is what? This one is angle in terms of degree. If now I put it is what? I put it in terms of radian. The full circle angle in terms of radian is 2 pi. This one I don't know the angle. I just put theta first. Times 2 pi r. 2 and 2 cancel off. Pi and pi cancel off. So S is equals to r theta. That's how the formula come from lah. So you know this one must be what? This one must be in radian. Only this formula you use degree. Okay. So always remember. If you use this formula S equals to r theta, always put it in what? In radian. A lot of students do what? Okay, I found the formula. I know the formula. I know the radius. I know the angle. S equals to R. Okay, maybe it's 5. And then the angle is 90 degree. Okay, good. I know the answer already. Oh my god. The answer why so big one? Huh? Why so big one? Because the unit is wrong. Remember to convert the unit into radian. This is the first thing lah. The arc length. The second formula you need to know is what? It's about the area. The area of sector. The area of sector is kind of similar to what? It's kind of similar to the area of triangle, but it's just a bit different. Area equals to 1 over 2 r squared theta. And same thing, remember, this theta is in term of what? In term of radian also. In term of radian. These two formula is basically the two formula you need to use in radian, okay? For other formula, you can just use in degree. But for this two formula, always remember it's in term of radian. So now maybe he give you one sector. The radius, this is the angle. So how to find the area of this? Easy lah, 1 over 2. This one, maybe this one is 5, right? 5. This one, he give you radian in term of 1.3 radian. So it's 5 square and then times 1.3. This one is the area of this sector. Area of sector. The third thing is what? The area of segment. So another recap. What is segment? Segment, how the segment form? Is this one a segment? No, right? This one is a sector. Segment is formed when what? When there's two lines that touches the circle, but without touching what? Without touching the center point. This one is center point. the two lines touch the circle outline without touching the center line. So what? This is what? So this will be your segment. This is the segment. Usually they will draw like this, like usually. They'll have something like this. And okay, they will draw one sector first. This is a sector. And then they draw one line from here to here, which is what known as the chord. So here will be the segment. The segment. The whole thing is what? The whole thing is a sector. Then how to find the area of the segment? Okay, now you think as what? This one is actually what? This one is an ice cream. Ice cream. And then this one is the ice cream cone. And this one is what? This one is actually a triangle. Now I only want what? I only want the ice cream on top. Maybe this one is I don't know, a mint ice cream. A mint flavored ice cream. I only want the blue part, okay? The ice cream part. I don't want the cone part. The cone part. So I use the whole thing, this one, the whole thing, the whole sector minus the cone part, then I can get the ice cream part. The whole thing, the whole sector area minus this one, the ice cream cone. Then you can get the ice cream part only. So how should you write? The area of sector, we just learned it. 1 over 2 r squared theta. Minus, this one is what? This one is a triangle, right? How do you find the area of a triangle? 1 over 2 r squared sine theta equals to the area of the segment, of your segment. If now you want to simplify the formula, also can. What do you see in similar? 1 over 2, 1 over 2, same lah. R square, same lah. So now you can write it as 1 over 2 r square. Theta minus sine theta will be your area of segment. And please remember, this one always in radian. And sine theta, you can put this as degree. Okay, if lah, okay. If you don't know about this, just leave it. But if you know that, oh, actually I can change the angle unit in my calculator today, then you can use the sine degree, the sine angle in terms of in terms of radian also. But in order to not get confused, you just remember for two formula, S equals to r theta and area equals to 1 over 2 r squared theta. In these two formula, you use the angle as radian, and other formula, you use the angle as degree. This is everything you need to know. Not everything lah, but most of it you need to know. But this is only the theory of it, just the formula or the formulae in plural. But the application is a bit different also. How do you apply it is a different story already. So now we come back to this question to end today's sharing. I didn't walk you through every single thing, right? Like you should know, you should learn on your own. I think that one shouldn't be a problem. Like how to do the substitution, the normal substitution for the arc length, for the area, and also and we'll learn about the perimeter also. But it's okay, we'll learn from this question. So look at when you go into exam, we're doing one exercise. The first thing, of course, look at the question. The question gives you all the info first. Diagram 3, here's the diagram 3, shows a circle with center O, right? As I said, usually they label the center as O, and the radius of 13 cm. Be careful, is it radius or diameter? If they say diameter, then OB should be what? OB should be 6 only. But they say what? Radius what? So radius here to here should be 13 cm. And here to here also 13 cm. If I ask you, if I put here to here, how much is it? Same lah. Here to here also radius what? So also 13 cm. So now what they say? QR and BR are tangent. QR and BR. QR and BR are tangent to the circles at point Q and B respectively. So the QR and BR are the lines, are the tangent line that touches the circle at point Q and point B. So remember what we say or not? Okay, here's the tangent line. If you draw one line from the center, to the tangent line, how much is the angle here? It's 90 degree. So now you know what? Actually here is 90 degree. If you draw one line from this O to this point Q, you know here is also 90 degree. And it's given that the length of BQ is equals to 24 centimeter. BQ is 24 centimeter. Which line is BQ? Here also some students, they will get confused. What do you think? BQ is 24. Okay, here is BQ. Here also BQ. Oh, which one is BQ? Is it the straight line or the arc or the curve one, the arc one? If they never say, if they say like the length of arc BQ, only you say it's this one. Only you assume this one as 24 centimeter. If they never say arc, you assume it as a straight line one. So here, the 24 centimeter is here. Here is 24 centimeter. Okay, here is the BQ with 24 centimeter. You only assume it as the arc if they say. If never say, then you assume as the straight line. By using pi equals to 3.142, remember this one, okay? You don't press the pi on your calculator. You use pi as 3.142. Find what? The first, look at A. The angle of BOQ in radian. In radian. Angle BOQ. Okay. Angle BOQ. How? BOQ. This is the angle you want to find. What is this angle? So now you think about the information you have. The first information you have is, remember what is the radius or not? This one is what? This one is 30 cm. This one, O to Q is what? It's also radius, right? So it's also 13 cm. Then here is 24 centimeter walk, 24 cm walk. Now you can think of what? Oh, I got how many sides? I got 3 sides. And then I got what? I got an angle. And then this angle is between 2 sides. What? I can think of what rule? Is it sine rule or cosine rule? It's what? Cosine rule. So I just need to apply cosine rule in order to solve the question. I mean, there's easier way, but later I'll talk about this. But the very obvious one I'll think about is the cosine rule. Okay, remember, this one is the angle and this one is 24. This one is 24, right? It's 24 square equals to, I just show you I show you again the general one. This one angle C, and then this one is length C. This one is A and B, length A and AB. And then the formula will be what? Will be C square equals to A square plus B square minus 2AB cos C. So here, what should the formula look like? Okay, if this angle is C, then here also C lah. So it's 24 square equals to 13 square plus 13 square minus 2, 13, 13, and cos theta. You don't know the angle, but you just put theta lah. Then just do your algebra, just move everything here, and then divide, then you should get the angle. But this angle is what? This angle is in degree. It's in degree. Okay, let's just say the angle is x in degree lah. You need to change the angle from degree to radian. Remember, the answer want you to put as radian. Now I got degree. I want to change to radian. How to change I times what? I want radian what? Times pi radian. I don't want degree. I divide by 180 degree. So times pi over 180. Do you press calculator like this? No. Remember, use pi equals to 3.142. So the angle you find times 3.142 divide by 180, then you should find what? You should find the angle in radian. This is A lah. But now, ayo, why you use cosine rule? So complex, so difficult. I don't want to use cosine rule. I cannot memorize the formula. What can you do also? The second thing you can do, or maybe you consider this as the easier way, is like this. I want to find the angle of here, but how? I can divide it into 2, and then I can form what? this is a right angle triangle, right? Here is a right angle triangle. This is maybe this one is O B. This is C lah, C. Okay, put it as C. So this one O B C is a right angle triangle, and the length here and here should be the same. So if the total length here is 24, I divide by 2. Here is what? Here is 12 lah. And then here the length is which is the radius is 13. And then you find the angle here. How to find? Now you got what? This one is right angle triangle, right? You can use sin cos tangent. But should I use sine lah, cos lah, or tangent? You see, okay, I got what? I got opposite. And then this one is what? The longest line, or the line opposite of 90 degree, which is the hypotenuse. I got opposite and hypotenuse. So it's using sine. Sine theta equals to opposite over hypotenuse. So sine theta equals to 13, 13 pula, 12 over 13. And then equals to sine minus 1, 12 over 13. You should find the angle. Then, oh, okay, I find the angle already. And then I convert to radian, then it's the answer. Is it correct? No. A lot of people also, the student, what they do? They do until here, okay, I find the angle already. Good job. I got the 2 marks. No. You only find what? You only find the half of it only. You need to find another half. So after you get the angle, you need to do what? Times 2. Then you find answer. So you can have 2 methods of solving the question part A lah. Usually I prefer doing the cosine rule, but doing this is also okay. But just remember to times 2 for your final answer. Okay, look at question B. Part B. Find what? Find the perimeter in cm of the whole diagram. Always read the what? Read the question carefully. A lot of people see, okay, perimeter, I want to find perimeter. Oh my God, here is what? The shaded region. I find the shaded region. I find the perimeter of this shaded region. No, you don't find the perimeter of the shaded region. He asked what? The whole diagram. What is the whole diagram? Everything. You find the perimeter of these. Okay? These. This is the whole diagram. Be very, very careful, okay? So how to find? So I think the easiest part is what? Easiest way is, first thing, you draw one line here. Here. Just now you find the angle already, right? You find B, O, Q, you find the angle here already. So you just need to minus the angle, then you can find the angle here also, the angle here. So by using what? The formula of what? Arc length. S equals to r theta. S is 13. The angle you just find out. This one is angle 2. The theta 2. Then you can find what is the length of VAQ. This one shouldn't be any problem for most of the student. They should like able to do this very easily. But the problem is what? What is the length of BR and QR? What is this? This one is what? This one is the time that we apply what? The tangent, the 90 degrees. You put 90 degree, and then you put 90 degree. And then you divide it into what? Into a 2 triangle. And you need to notice something. Actually, these 2 triangle, triangle 1, triangle 2, they are exactly same. Why leh? Okay, look. This one, the angle here, you divide by 2, right? So imagine, just let's say this one is 60. So here is 30, here is 30. The angle here is same. This one is what? This one is radius, what? Radius 13 cm. Here also radius 13 cm. So the length also same, what? Then the angle also same, the length also same. And then the here also should be same, what? If it's 30, 90, this one is 60, 60. Everything is same. The length here also same. So, if you know this info already, actually BR is what? BR and QR is what relationship? BR actually equals to QR. And now you have what? You have triangle, right? How to find the length from this right angle triangle, also using sin cos tangent? You draw it out something like this. Wait, let me just delete other stuff so you can see it more clearer. Like this. If I draw the triangle, O, B, R, triangle. This one is 13 cm. This one is the angle you found lah, divide by 2. And now you want to find what? You want to find BR. BR is your X, the unknown you're trying to find. Okay, X is actually what? Is it hypotenuse, or is it adjacent, or is it opposite? Very obviously, this one is the opposite of it. This one is O. Then 13 is what? 13 is adjacent. Why? Because here is hypotenuse. Opposite of 90 degree is hypotenuse. So here is 13. This one is your adjacent. So your sine, the angle, you sub in, divide by 2 equals to what? Equals to sine block, tangent. Tangent, angle, over 2 equals to the value you're trying to find, which is the BR over 13. So the 13 you move up, divide, then you move here is times. So BR is equals to 13 times tangent theta over 2. Then you can find BR. And BR is equals to QR, right? Then you just get the answer, you times 2, and then you plus with this one, then you should get the answer, the perimeter of the whole diagram. Only 3 marks actually. Finding the area. Find the area of the shaded region. And now we only talk about shaded region. How to find the area of shaded region? Okay, you need to analyze. The shaded region is actually consists of what shade? If you look the shaded region like this, oh my god, what is this? How I find this one? You might be very confused lah. But actually we can break it down. Like how? We can draw another line here, another radius here. If we draw a radius here, right? Here's actually what? Here is a triangle. A triangle. And then here is what? Here is a sector. So we need to find two areas first, then we times them up. This one is the first thing, this one is the second one. The area of sector 1 over 2 r squared theta plus the area of triangle 1 over 2 r squared sine theta. Remember, here is what? In terms of radian. Then you substitute all the value inside, then you should get the answer lah. Okay, some students, they're gonna find what? They're gonna find the angle of this. What is the angle of this? I know this one. I know this one, right? Okay, this one with this one theta 1 lah. This one theta 2. I know theta 1. But I don't know theta 2. How you find? This one is a line then. This one is a diameter, right? Here is what? Here is what? This one is half lah. Here is 180 degree or pi. So here is also pi. So just use for theta 2, you use pi minus theta 1, then you should get pi the theta 2. So the area is just like this. So this one is just for you to like know how to apply the formulas that you learn in the circular measure. So for circular measure, actually this chapter only have the new formula that you learn is only 2 lah. Okay, actually just only 2. S equals to r theta and area equals to 1 over 2 r squared theta. But the application is a lot. You need to apply the other formula that you learned before. So this one is just a very, I think it's quite long explanation about circular measure, but I only explain one try question and I just briefly talk about this. If you like a video like this that explain about how to do the question, explain about the formula, how they come from, then maybe I'll consider doing other videos that showing how to solve trial questions that are similar to your SPM question lah. And that's all for this video. Thank you.